Okay, so we're recording now. And let me try to share the screen. Okay, now the formal business that I have for tonight is actually not going to be that long. Temporarily ignore the rest of the schedule, but okay, so our exam is on Thursday. I was just about done with 12.6. I will finish up 12.6 today and start 13.1. Okay. Anything I do from chapter 13 is not going to be on Thursday's test. Okay. Chapter 13 is actually our shortest chapter. There are only 1, 2, 3, 4 sections. Okay, so we just completed chapter 12, right? So the test is Thursday, chapter 12. Chapter 13 is only 4 sections, so that test is going to come pretty fast. On the calendar, I have it for Tuesday the 23rd. So let's keep that date. I may actually be able to finish before that since I messed up here. I actually have a couple of days left over, but I'm not going to change the date. So even if I finish early, I'll just go right into the next chapter. And then the chapters after that are much longer, actually. So chapter 14 has 8 sections, 15 has 9, and 16 also has 9. Okay, so the next test will come pretty fast. Chapter 13, there's only 4 sections. Okay. All right, so some reminders. You might say you're repeating yourself a lot. That's true. I have a lot of repetition. The reason for repetition also is I don't catch everybody. Some people didn't get it the first time, or some people were absent. And also, if I say something 2 or 3 or 4 times, then you really shouldn't have any excuse for anybody to say, "Oh, I didn't know this was the rule. I didn't know you did that." You know, I've been saying it like 2, 3, 4 times, right? Okay, so I'm hoping for today to do 12.6 and 13.1 before the break. If I don't, I can do 13.1 after the break. And then after that, I'll let you ask questions on anything here. Okay, so if you have any questions from here, bring it up if you wish. I'm gonna let you ask next time, but if we have most of the question and answer done today, then we don't have as much need for questions and answer Thursday, in which case I can give you more time on the test on Thursday. Okay, so I believe I can finish 12.6 and 13.1 first half. Okay. Second half, Q&A. You have any questions from here? Namely here, bring it up. Okay. If not, I could technically end early, or maybe I'll just sneak in some of 13.2 also. Okay. And then Thursday, I'm not giving you the entire time for the test. Now, some of the tests at the end, especially test 4 and test 5, and maybe even test 3, you might need the entire period because some of those problems are just so long, but not for Thursday. So game plan for Thursday is I'll lecture a while, quote unquote. And what is a while? Maybe half an hour, 40 minutes or something like that. And then again, a question and answer session. Then we break. And then after the break, I'll give you the test. Okay. So I'll send you the test on Canvas announcements, but I'll also project it. Some of you like it better if I project it over here like a quiz. And you have the rest of the time. So if it turns out to be more than 15 minutes, great. So I only promise you 50 minutes. So 50 minutes means we would have to start the test by what? We end at 8:25, so 7:30-ish at the latest. But if we start earlier, I don't mind, then you have more time. Okay, if you finish early, then that's fine. Okay, so I will end class as normal at 8:25. And then you have 5 minutes to take a picture on your cell phone, click, 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 just like the quizzes. Okay, so I need to test by 8:30. Then I'll give you another half an hour, which is 9:00 p.m. to submit the homework. Although if you want to turn in your homework early, that's fine. Okay, I'll take the homework right after class, you know, anytime from now until Thursday, that's fine to submit the homework also. Okay, and then for the exam, you get one cheat sheet, so one formula sheet. Put all the formulas that you want from the chapter, you know, cross product, dot product, scalar projection, vector projection, you know, all the other stuff. You can put it all on your formula sheet, direction angles, direction cosines, put it on your cheat sheet, okay? And you can use that. Technically, you cannot use anything else, okay? So after that, and you can use a calculator, but no books, no notes, no people, no internet, no computer, right? That's not allowed, okay? And this is not a guarantee you're not going to cheat, but again, I already have a sample of your writing from the quizzes, right? And you'll submit the homework. Same thing. So just take a picture on your cell phone, click, 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 and you submit the exam same way. Okay. So for the homework, I just check off that you did it, but I will look. I will look. Hey, the handwriting on the quiz isn't the same as the handwriting on the homework, and it isn't the same as handwriting on the exam. I get very suspicious, right? Okay. And I think you can see where I'm coming from. A student might get somebody to cheat for them on the test, but you're much less likely to find somebody who wants to, do all the homework for you, right? Okay, so that's one of the reasons why I do it that way. Okay, so you must submit the homework, 70% requirement. Okay, so if you do not submit at least 70% of 12.1 to 12.6, then I do not grade your test. You automatically get a 0. And it's not that hard to do because I do a great percentage of it anyway, right? What do I end up doing? Half of it, maybe even more than half, 30%, whatever. It's not that hard to make the 70% requirement, right? And let's see, during the test, so that's the only time for sure you have to have your actual camera on. So during the test, you must have your camera on, the true background. So don't show like the Golden Gate Bridge or anything else. It's got to be your actual background. Keep yourself muted. During the test, if you have any questions, put it in the chat. I mean, just think if we were meeting face to face on a test, I wouldn't want you to just yell out, right? Hey, I have a question about number 7. You don't want to do that during face-to-face meetings, right? So you shouldn't do that during the test either. So just put the question in the chat and I'll answer you via the chat. Okay. So that's the way the test is. So if you have any questions, bring it up today. So next time I'll lecture a little while, quote unquote. I'll let you have question and answers. And if whenever that stops, then break and then take the exam. Okay. Now I do know some of you put something in the chat. So I'll go ahead and try to catch some of the questions. Let's see. So again, 13.1, no, you don't need to turn in anything from chapter 13. Okay, so chapter 13 will be on the next exam. Okay, so you will turn in Thursday just 12.1 to 12.6, i.e. just everything up to here. I will start 13.1 today, take notes or have it, it's on the video, but don't even really bother with it until after the test on Thursday, I would say. Okay. How many questions on the test? I usually give about 10. Okay. So roughly 10 questions. No, we won't have another quiz. So I don't give a quiz and a test on the same day. That's, a little bit too much, obviously. Okay. And so you don't have to turn in chapter 13 until the next test, which is 223, it looks like for now. Okay. All right, so once I knock off the last little piece of 12.6, then that's it for coverage of the test. So once I get started with 13.1, go ahead and take notes and all that, but don't submit that. You don't need that for the homework and all that. I would even say don't even look at it until after the test on Thursday. Okay. And yeah, 10 questions. So 13.1 is exam 2. Yes, that's correct. Should you have 13.1 prepared by next Tuesday? You don't have to have anything in chapter 13 prepared until next Tuesday after you take the test. However far I get on Thursday. So let's say Thursday, by the end of Thursday, I'm actually finished lecturing on 13.2, then yes, you should have that prepared after you finish the test. Okay, cheat sheet is both sides. So one sheet of paper, front and back. Okay, put any formulas that you wish. Yes, the cheat sheet should be just on paper. You write it on a piece of paper. I can't allow iPads, sorry. I mean, and I know that you can shrink it down real small. And if you shrink it down real small, you can get quite a bit. So it has to be handwritten, please. And I think I've caught up with the chat. Okay. All right. So I think I've caught up. If not, you can put it in the chat again. I'm going to close that up right now, though. And let's see. Calculator is always allowed. So yeah, you can have a calculator for any exams or any quizzes and so on. Okay, so I'm going to turn off the chat. Go ahead and keep typing if you wish, but I'm going to knock off the last problems that I had, which are 18 and 20. So I would have done all the evens. Again, it didn't really matter if I did the evens or odds. You don't have the answers to the odds anyway because I'm doing them differently. Okay, so it was 11 to 20. I did 12, 14, and 16. And let me do 18 and 20 for you. Get that out of the way, and then we're finished. Okay, so 18, please. 3x squared minus y squared plus 3z squared equals 0. Okay, so find the traces in the coordinate planes. Okay, so that would be the language I would give, right? So a question on the test might say, give the traces in the xy, yz, and xz planes. Okay, so we already know what that means. X equals 0 means the yz plane. Y equals 0 means the xz plane. And z equals 0 means the xy plane. And yeah, if you want to put that on your cheat sheet, you may. But just about on the very first day, right? First day we did that. Okay, that if you have one of the variables equals 0, then it's the plane of the other two letters, right? All right, x equals 0. Put a 0 there. That means it's gone. Negative y squared plus 3z squared equals 0. Okay, if I move the y squared over, you have y squared equals 3z squared. Then by the square root property, that says y is plus or minus radical 3z. Okay, or solving for z because z is functioning like y, right? I know our brains are kind of messed up now. We're used to the x and y, but if you have y and z, we said z is what used to be y and y is what used to be x. So I solve for z. Z is plus or minus 1 over radical 3y. And both of these are lines through the origin. Okay, and you don't have to graph it very accurately. Okay, but 1 over radical 3, 1 over 1.7, so that's like 0.6. Slope is plus or minus 0.6. Okay, so you have two lines, like so. Right? So that's x equals 0, the x equals 0 plane. So if I were to look in the direction of x equals 0, this is what I would see. Now, y equals 0. Put a 0 right there. It's gone. 3x squared plus 3z squared equals 0. We saw something like that last time. Divide by 3. X squared plus z squared equals 0 is just a single point. 0, 0. So that's what it looks like. So if I look in the xz plane, which means y equals 0, it's just a single dot. Again, I suppose you could say this is a circle centered at the origin with a radius of 0, right? So it's just a single point. Okay, notice if I put any number in besides 0, you're going to get a positive quantity here. And so there's no way this can be 0. All right, and finally, z equals 0. So make that 0. I have 3x squared minus y squared equals 0. Okay, so again, I added y squared on both sides. It'll be y squared equals 3x squared. This is our normal y versus x. Okay, so y equals plus or minus radical 3x. Okay, so slopes are plus or minus 1.7, and that's what it looks like. Okay. So that's that. Okay, then question 20, and then I'm done. And then I'll get started with the next chapter, which will not be on the test, of course. I do see some of you putting stuff in the chat, so I'll get to that after I do this last problem. Okay, 20, x equals y squared minus z squared. Okay. All right, so again, the directions in the test might say something like, give the traces in the xy, yz, and xe planes. Okay, and yeah, side note, I usually give about 10 questions, so there's 6 sections. So that means at least 1 question from each section, and most of the others will have 2. Okay. I think the most likely scenario is I'll only ask you 1 of these. I mean, if you know how to do 1, you got them all. So probably only 1 question from 12.6, if that helps. And then all the other sections, therefore, maybe roughly 2. And by the way, the 10 questions is not a promise. I'm not promising you 10, but about 10. Definitely not 30, and definitely not 5. Okay, so about 10 means maybe 9 or 11, and in extreme cases, maybe 8 or 12, but definitely, quote unquote, around 10. Okay, x equals 0. If x equals 0, that means y squared equals z squared. Just add that over. Y squared is z squared. That means y equals plus or minus z, do the square root property, or z is plus or minus y. So just lines going through the origin, slope of 1 and negative 1, y, z. Again, remember the convention is anytime z is involved, Okay, now that we know that z is the height going up, okay, in x and y was the height. And remember we said at the first day, oh, this is dumb, why don't we just leave y alone? And we'll see later, there's good reasons for letting z be the height. Okay, so if z is involved, it's the height. So z and y, z is the height. Z and x, z is the height. And you don't have to wonder about x and y. X and y is just like we used to. All right, so z is plus or minus y, slope of 1 and negative 1. Okay, y equals 0. Put a 0 there. X equals negative z squared. Okay, so x and z, I have to think like x and y. So x equals negative y squared. That's the way I think about it in my brain. Okay, that x is like this is like y. So x equals negative y squared. It's, oh yeah, it's a parabola opening to the left, you might recall, from your analytic geometry that hopefully you had before. And those of you that had me in Calc 2, we went over this, and hopefully your Calc 2 teacher did some analytic geometry like this. And finally, z equals 0. So z equals 0, x equals y squared. X equals y squared is a parabola opening to the, see, y is positive, x is not, and squared and y, that opens to the right. So x equals y squared. And there we go. All right, folks, so I have officially finished 12.6, and that means I'm finished with everything I was planning to cover for this Thursday's exam. Okay, so right now I'll get started with 13.1. Let me clear the chat first. I'll get that out of the way. Again, after the break, if you want to ask me questions about chapter 12, I can do some today. The more we do today, the less we can do, or the less we have to do Thursday, and then maybe I can give you more time for the test. Okay, so again, I was not planning to give you the entire time for the test on Thursday, but I'm willing to give you more time if we knock off as many questions as possible after the break, perhaps. Okay, so let me check the chat real quickly and see what we have. Okay, can you turn in the cheat sheet? I don't need the cheat sheet. Okay, yeah, sorry, this one I need you to actually write. I don't want you to have your iPad. Okay, so no typing. Okay, you've all written, because if you type, you know, somebody could type for you, but I need to see you write it just like the homework and so forth. Okay, so literally writing on piece of paper for this one, sorry. That's the way I need it. Okay, and I think I can do that. Okay, so I think I've caught up. All right, so that's that. I'm going to start 13.1. You can take notes, but you know, don't really look at it until after Thursday's test. Okay, so I'll get started, and you don't have to turn in any homework for 13.1 either. And yes, if you want to continue putting stuff in the chat, you may. But beginning of chapter 13. Topic is vector functions. 13.1, vector functions and space curves. Okay, now you don't have to have a space curve. You can have a two-dimensional, function, and you can obviously tell by how many components there are. Okay, so we have R of t. R again stands for a position vector. Okay, so R is for position vector. And if you want to put that down, you may. Okay. Talked about that before briefly, but R is a possession vector, which really means the vector is X, Y, Z. So if you ever see R in our class, well, it could be two-dimensional. It's just X and Y. Okay, or you're going to have X, Y, and Z. So the components are X, Y, and Z. Okay, so you can write it either this way or this way, right? F of t, G of t, H of t, or F of t I plus G of t j plus H of t k. Okay, and as I've already told you before, I don't like writing extra stuff unnecessarily. I'll write I, J, and K occasionally for the rest of this semester, but most of the time, save writing, I'll just do the angle basis. All right, so here is a vector value function. which is really three functions in one. Okay, so R of t is, can't even read it, t cubed ln 3 minus t radical t. So you have three functions, x, y, and z. So this is how x changes with time. Yes, the most likely scenario is the passage of time. So t standing for time. Then how does the x coordinate coming in and out of the board or the paper, how does that change with time? How does y change left and right with time? How does z change up and down with time? And there we go. So we have three functions, okay, but we're calling it all one function. So this is one vector value function, okay, but it's made up of three. Okay? Or if it's a two-dimensional situation, then the one vector function is a function of two variables, x and y. And you went over some of that's parametric equations in Calc 2. You remember doing parametric equations in Calc 2? Those of you that had me, we did parametric equations. X is equal to blah, blah, blah. Y equals blah, 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 right? And you can graph it from there. So same thing, parametric equations, except it's 3D. Okay. Now, you can take limits as usual. Okay. Take the limit of the first function, second function, and the third function. Okay. And what's going to happen is this will generate a space curve, a three-dimensional curve. So figure 1 is an example, page 849. So they give me blue box number 2, x is a function of t, y is a function of t, z is a function of t. So if you only look at the x direction coming in and out like this, okay, then it'll change with time. And then if you only look at y, left and right, it'll change with time. And then if you only look at z up and down, it changes with time. And put them all together, and you generate a space curve. So here's an example of a space curve. Okay, so here's a given point, f of t, g of t, h of t. And yes, this could be thought of as the passage of time. So at t equals 7, or t equals 3, or whatever, you plug it in, and then you have a particular position in space. Okay, so the vector value function, r of t, okay, so we call it one function, a vector function, but it's made up of three functions, okay, x, y, and z functions. Okay. All right, so they will give it to us either like this, right, or like this. We already know this is x, y, and z. So r of t is always x, y, and z. Position vector. Position vectors always emanate from the origin. So they emanate from the origin. And the nice thing about having a position vector is if I apply the vector x, y, z, what point do I end up with? X, y, z, right? So it emanates from the origin. So they might write it like this. So anytime in the rest of this book, if you see r of t as a vector, that's x, that's y, that's z. Now be careful, that's not always going to be true. Okay, so if they just give me a vector in general, like a vector v or u or n or whatever, the components are not necessarily x, y, and z. But for a position vector, if it says r of t, then yes, x is that, y is that, z is that. Okay. Okay, now, the nice thing about this, but it's hard to see, is you can generate three-dimensional objects, okay, like the DNA double helix. You can write a formula for that. Okay, here's some neat pictures, which I cannot draw. Computers can draw, but I'm not making you do computer generation for all these. And this looks like an ellipse in space. It kind of goes like this. And you have some funny things like that. And figure 8, I don't know what you call that. Well, you got a name there, trefoil knot or something weird like that. Okay, so if you were to plot these, computer generated, as you can see, then you end up with funny pictures like that. But you can see it's very, very rich in the kinds of things that you can do. Obviously, I'm not going to make you draw anything like that. I will have you draw something quote unquote easy. And from my definition of easy, easy is something that I can do, right? Straight lines, but maybe a few curves you should be able to draw, okay? All right, just side note here. They have this, and what are they doing here? they're doing traces just like I showed you, right? If you trace in one particular direction, it looks like this. If you look in another direction, it looks like that. These are two-dimensional, right? So if you look at a certain angle, if you look at this thing at a certain angle, they're trying to draw you a three-dimensional picture here. But if you look at a certain angle, it kind of looks like that. From another view, it looks like that. From another view, it kind of looks like that, right? So that's exactly just like a trace as I did in section 6. All right. Now, a lot of the homework I'm not having you do because you're forced to draw stuff or come up with, things like that. Nice pictures, but it's very difficult to understand what's going on to analyze it. So I said, okay, we won't bother with that. But just know that having these vector valued functions, right, where R is a function of X, Y, and Z, put them all together and you get neat shapes like that, or like that, or like that, or like that. Okay, so the only thing I'll say, let's say about this thing, it looks from the picture that Y cannot be negative, right? This thing is shooting out to the right, so Y maybe is 0 and positive, but whatever the function of Y is, it cannot be negative. Okay, and maybe this one, it looks like Z cannot be negative, right? From that first quadrant, first octant view, it looks like the Z values are up here, but it doesn't seem to go down, and so on. Okay. All right, so how do you do some of the problems now? Number 1, find the domain of the vector function. Okay. So you have, we're calling it one function, but there's really 3 functions. Okay, they got ln t plus 1, t over radical 9 minus t squared, 2 to the t power. What's the domain? Okay. Now, if a t value is in the domain, it has to work for all 3 of them, right? It means no good. Let's say I can tell right away, 3 is no good, right? If I plug in 3, I'm dividing by 0, can't do it. It doesn't matter that I'm allowed to plug in 3 here and I'm allowed to plug in 3 here. No, the t that I pick has to satisfy all 3 of these, right? So I have to find restrictions on this one and this one and this one. I can only pick the t values that make all of them work. Okay, so I just treat them one at a time. So number 1, 13.1, page 853. Okay, so the vector function R of t is ln t plus 1, t over radical 9 minus t squared, 2 to the t. Okay, so this is for x, this is y, this is z. So I consider the domains of all of these. Okay, let me get the z out of the way. Z. 2 to the t, that's defined for all real numbers, right? That's never any problem. Okay, so from z, there's no limits for t. No problems for that. Okay, how about x? ln t plus 1. Do you recall what's the domain of the natural log function? I'm only allowed to take the natural log of positive quantities. That means t plus 1 must be greater than 0, and that means t is greater than negative 1. Okay, so for sure, I cannot plug in negative 1, because if you plug in negative 1 here, right, you end up with 0. And I'm not allowed to let t be anything less than that, like negative 2, negative 3, negative 4, negative 1,000,000. Those are not allowed, because then I'll be taking the ln of a negative. Okay, and then how about y? T over radical 9 minus t squared. No trouble with the top, but the bottom, 9 minus t squared, has to be greater than 0. Okay? Not even greater than or equal to 0. Now, if I only saw this, just radical 9 minus t squared, then 9 minus t squared greater than or equal to 0 is okay. I can take the square root of 0, right? Square root of 0 is 0. But once you put it in the denominator, now 9 minus t squared must be greater than 0. Right? Okay, so I move over to t squared. 9 is greater than t squared, and that means t has to be between plus and minus 3. T between negative 3 and 3, right? Oh, I'm sorry. Strictly less than, not less than or equal to. Okay, t squared less than 9 means t between negative 3 and 3. Okay, this has to be true, and this has to be true. And z had no trouble, right? 2 to the t. Okay, so put them together. I have parenthesis, -1, comma 3 parenthesis. Okay, so t has to be between -3 and 3, and t has to be greater than -1. So that means stuff between -3 and -1 is thrown out. So put them together, -1 to 3. Okay, so that's the way that one works. 3, find the limit. Limit as t approaches 0, e to the -3ti plus t squared over sine squared tj plus cosine 2tk. And of course, you know the way I'm going to write it without the I, j, and k. Folks, it's not really that hard. It's really 3 in 1. Okay? Imagine you're back in Calc 1, and this is, 3a, 3b, 3c. Like, find the limits. Find the limit 3a, find the limit as t approaches 0 of that. 3b, find the limit as t approaches 0 of that. 3c, find the limit as t approaches 0 of that. So 3a, 3b, 3c. In fact, I can even be more specific. This is like 3x, 3y, 3z, because this is literally x, y, and z, right? All right, now these two are just straight plugins, right? From Calc 1, what's the limit as t approaches 0 of e to the -3t? Just plug in 0, you get 1. And z is also easy. T approaches 0, cosine 2t, plug in 0, cosine of 0 is 1. This one's a little bit harder maybe, but you might recall from Calc 1, I want the limit as t approaches 0. And by the way, it's the limit as t approaches 0 of all of them. I can rewrite this as t over sine t squared, okay? And you might recall from Calc 1 that this limit was 1. Okay, that was one of the fundamental differences, or maybe it was sine t over t. But if the limit of sine t over t as t approaches 0 is 1, so is the limit of the reciprocal, it's also 1. Or you might recall you can do L'Hopital's rule. Right? Remember L'Hopital's rule quickly? If I plug in, I have 0 over 0, which means I can take the derivative of the top, derivative of the bottom. Derivative at the top is 1. Derivative of the bottom is cosine t. Then when you plug in, you get 1. And you square it, you get 1. Okay, so the final answer is 1, 1, 1. Okay, oh, I made a mistake. The limit should be a vector, right? Not the point 1, 1, 1, but the vector 1, 1, 1. Like so. Okay. So that's limits. I'll let you do 5 likewise. Okay. I'm having you do a few sketches. Now you should be able to do any 2-dimensional sketch, like 7. Again, how do I know it's 2D? It's only 2 components. The 3D ones get very difficult and funky and all that stuff in it with stuff like that. But for some quote unquote easy ones, I think you should know how to do. Okay, so I'll show you 7. And then I was going to, let's see, 9 should not be that bad. And then I was going to do for you 13. Okay, so 7, R of t is sine of t and t. It's 2-dimensional. So x and y. All right, so since it involves a trig function, I just made a table. Okay, you should have done some of this in Calc 2. Those of you that had me, we definitely did this. So since it's trig, I went -2 pi, -3 pi over 2, -pi, -pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi. Here's if you can't see it. Maybe that's a little bit better. I went from 0 to pi over 2, pi, 3 pi over 2, 2 pi, and the negative. Negative pi over 2, negative pi, -3 pi over 2, -2 pi. Okay, since y equals t, I just copy. So all of these, I just copy over here. But when I plot it, I need the approximate value, right? Like I know pi is about 3.1, 2 pi is 6.3, and so on. And that's -6.3 and -3.14, and so on. Okay, then a little bit of trig. So sine of 0 is 0. for the x coordinate. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. And then, yeah, just copy and paste. That's one period, so go back 0, 1, 0, negative 1. Okay, then I just plot x versus y. As usual, I get something like this. So here's 0, negative 2 pi. Okay, x is stuck between negative 1 and 1. Okay, that's 1 comma negative 3 pi over 2, roughly around there. 0, negative pi, negative 3.1. I put about negative 3 and so on. Okay, and then negative 1, negative pi over 2. Origin, and so on. Okay, so it ends up looking something like that. Okay, so that's that one. And then I was going to show you 13. I need to show you at least one three-dimensional one that I want you to try. Okay, they're not necessarily easy, but give it a shot. Okay, so let's see. 13. I will say you should be able to do 9 pretty easily because it's linear. Linear, linear, linear. Okay, I'll do 13. T squared, t to the 4th, t to the 6th. So r is t squared I plus t to the 4th j plus t to the 6th k. All right. Plug in 0, 0, 0, 0. Plus or minus 1. Either plus or minus 1, 1, 1, 1. Plus or minus 2. Well, 2 squared is 4. 2 to the 4th is 16. And 2 to the 6th is 64. Okay, so z goes up real fast. X is not fast at all. And then y. Okay, so I just do a first octant picture, right? X, y, and z cannot be negative. So first octant goes through the origin. Okay, 1, 1, 1. I mean, yeah, we're just pretending. Imagine you go 1 this way, 1 this way, and 1 this way. So I kind of have it going like this. And then this one, 4, maybe here. 16 is farther out, and 64 is way up. So it shoots up. Okay, so very crudely, I just have something going up like that. Okay, that's pretty much about it. All right, see what time is it? We're okay. So just going to show you a couple more. So 19, I'll show you, and 27, no sketch, whatever that means. So we'll see. Okay, 17 and 19, find a vector equation and parametric equations for the line segment that joins P to Q. So 17 and 19 are the same, but 19 looks harder. So I'll do 19 for you. Okay, so if you're going from point A to point B, then you use this formula that I showed you before. Page 826, 12.5, that one. In fact, that might even be on the test. Right, so R of t, okay, you're going from R0 to R1. R of t is 1 minus t R0 plus t R1, t goes from 0 to 1. Okay, so from one point to another point, that's what you're going to use. Okay. And yes, I messed up. Okay, so from P to Q, 0, negative 1, 1 to 1/2, 1/3, 1/4. All right, so by 4, and this is considered R0 in braces. This is R1 in braces. Okay, so again, when I write parentheses, that's a point. Change it to brackets, it becomes a position vector. So these are position vectors. So by the formula I just showed you, R of t is 1 minus t R0 plus t R1 as t goes from 0 to 1. So what is R0? It's 0, negative 1, 1, but you write it as a vector. Please notice that. And R1 is 1/2, 1/3, 1/4, but also write that as a vector. And all you do is put 1 minus t in front of the beginning point and t in front of the ending point. And there it is, and just clean it up. Okay, so that's the way that one works. So one more time, take the point, write it as a vector. Take that point, write it as a vector. 1 minus t here, t here. Okay, so combine the x components. So that times 0 is 0, and that's half t. Okay, oh, I know, I just distributed here. So 1 minus t minus times nothing. 1 minus t times negative 1 is t minus 1. 1 minus t times 1 is 1 minus t. And then plus t times half, 1/3, 1/4. Okay, then I add x components, 0 plus half t, t minus 1 plus 1/3 t, t plus 1/3 t is 4/3 t minus 1. And then 1 minus t plus 1/4 t is 1 minus 3/4 t. So that's R. Okay, and then write it as parametric equations. So there it is. X equals half t, y equals 4/3 t minus 1, z equals negative 3/4 t plus 1 as t goes from 0 to 1. Okay, so parametric equations. And you should know how to change it to symmetric equations, right? Symmetric equations might be on the test. Just solve for t. T equals, you know, whatever. And you can put it on your formula sheet if you haven't already done so. Okay. What time is it? Not even 7 yet? Okay, I'll do 27 then. I think I'm done. Okay, 27. Show that the curve with parametric equations, x equals blah, 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 y equals blah, 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 z equals blah, 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 okay, can be written as z squared equals x squared plus y squared, and use that to help sketch the curve. Okay, so don't sketch it. So that must be what I mean by no sketch. Where'd it go? Yeah, you don't have to sketch it. Just show what they have. Okay, so show that z squared equals x squared plus y squared. Okay, so I just do it. Okay, so what is z squared? T squared. And then I find x squared plus y squared. So x squared would be t squared cosine squared t. Y squared is t squared sine squared t. Factor out the common factor of t squared. T squared times cosine squared t plus sine squared t. And we know cosine squared t plus sine squared t is 1. So I end up with t squared. So that's the end of the proof. Yes, indeed, the left-hand side is t squared. The right-hand side is also t squared, which means z squared is indeed x squared plus y squared. Okay. And you don't have to worry about the graph. And there we go. All right, so I'm done with that, folks. We're just about to break. Let me try to catch up with the chat. Okay. Okay, I see. If you're writing, yeah, the main thing is it has to be writing. Okay, so writing, not typed. Okay, if I type, somebody else can type it, but if you're writing on it, then yeah, I accept the writing. That'll be fine. Okay. All right. It's break time.
I had a quick question on the on number 13 there.
Oh boy. Okay. Go ahead. I just turned off the shared screen. So if do I need to share the screen again? I have to put it back.
No, I don't think so. It was just the direction of the arrows, which way it was going. It looked like you had them going in 2 directions.
Ah, I see what you're saying. The arrow's going 2 directions. That's correct. It is both directions because coming down, that's t going from negative infinity to 0, and then going back up from 0 to infinity. So yeah, the arrows were supposed to be going both directions.
Okay. All right. Got it. Thank you.
All right. Welcome. Anybody else? Okay, I got 6:57. So let's break until 7:10. Okay, and I'll start off by letting you ask questions. So if you want to ask me stuff from chapter 12, we can do that first. And if that's not, and I'll let you have the rest of the time for that. And if not, I'll sneak in a little bit of the next section, but otherwise we very well may end early. Okay, so break time until 7:10, all right? Okay, folks, so start back up, but a lot of this is dependent on how much you want to do. And let me try to share the screen again. Get there. I know it's kind of awkward, sorry. I mean, there's no way I can do this fast, as I think a lot of you know. Okay, some questions again about the submission. Yes, whatever you did in the quiz is okay for me on the test. So some of you were writing on a tablet or something, as long as it's in your own writing, so I can see your actual handwriting. It's not typed and looks nice and neat and pretty and all that stuff, but then I can't distinguish between your writing and someone else's. So if you have a tablet of some sort where you can write on it, that'll be fine. Okay. All right. Now, I have done all I was going to do with 13.1. Okay. I was going to let you have as much time as you wish now to ask me stuff from here, if you have any. If not, I'll sneak in some of 13.2, and then we'll probably end early. And we might end it early anyway, depending on how many questions you ask. Okay, so again, next time, I will start by lecturing on 13.2, not too long, which means maybe half an hour at the max. Let you ask questions, break, and then take the test. Okay, so the fewer questions there are, the more time I can give you for the test. And that means also the more questions there are today that you might have, then the less we have to do on Thursday. Okay. Again, you must submit the homework, 70% requirement. You must turn in at least 70% of the homework, but hey, I end up doing quite a bit of it anyway, right? Half, a little bit less than half, a little bit more than half, whatever. It's not that hard to have the 70% requirement. Okay. All right, so if you want to start typing in the chat, you may, or if you want to unmute yourself, you can do that also. Otherwise, I'll sneak in some of the next section. Okay. So I do see some people putting stuff in the chat right now. So let me start marking some of this down if I can. Okay, so 12.5, 59, and 21, 13, and 15. In the YZ plane. Okay, maybe I'll just do them all anyway from that. That's all I have here. And let me see what else is in the chat. Sorry. All right, so I see 12.5, number 21, 59, 12.6, 13, and 15. Okay, so I'll start off with that. It's probably not going to take me that long to do these. So if nobody else has anything else, we're probably going to end early. All right, so book here. Okay, 12.5. Let's take a look. Whoops. 12.521. Determine if the lines are parallel, skew, or intersecting. Okay. So L1, x minus 2 over 1 equals y minus 3 over negative 2 equals z minus 1 over negative t. And I'm going to sneak in equals t. And L2. See. Sorry, I'm trying to get myself a little organized here. X minus 3 over 1. Y plus 4 over 3. Z minus 2 over negative 7. And I'll call that S. And let me double check that I wrote it correctly. X minus 2 over 1, Y minus 3. T. Nope, I wrote it wrong. X minus 3. Y plus 4 over 3. Z minus 2 over negative 7. Okay, I think I'm good now. Okay, I think the best thing to do is to write them in parametric equations. So solve for x. X is 1 times t plus 2, t plus 2. Y is negative 2t plus 3. Z is negative 3t plus 1. That's for L1. Do the same thing for L2. X equals 1 times s plus 3. Y is 3s minus 4. Z is negative 7s plus 2. Is that a negative 7? Yeah, negative 7. Okay, so the vectors are 1, negative 2, negative 3, and 1, 3, negative 7. They are not scalar multiples of each other. Okay, so V1 direction vector is 1, negative 2, negative 3, and V2 is 1, 3, negative 7. They're just the coefficients of t and s, and 1 is not a scalar multiple of each other, so they're not parallel. Okay, so V1 is not equal to some constant times V2. Okay. So let's pretend this was 1, negative 2, negative 3, and this came out to be 2, negative 4, negative 6, right? So then this is just twice as big as this. So then the two lines would be parallel because they have the same direction. One is just twice as big as the other. Okay, so they're not parallel. Are they intersecting? Okay, the paper's curling on me. Let me try to uncurl it. All right, so I set these equal to each other. I mean, if they're going to have the same x, y, and z, then this has to equal this. T plus 2 equals s plus 3, which means t is equal to s plus 1. Subtract 2. Okay, t equals s plus 1. Plug that back into here, let's say. So y is negative 2t plus 3, and t is s plus 1. Or y equals negative 2s minus 2 plus 3. Minus 2 plus 3 is plus 1. And I also have y is equal to 3s minus 4. Okay, so both of these have to be true. So both of these are true, then I just set them equal to each other and solve. Negative 2s plus 1 equals 3s minus 4. Let's see, add 2s, add 4. 5 equals 5s. So s is equal to 1. S equals 1, t equals 2. So I plug that in there. Now I plug in and see if I get a consistent or inconsistent system. Okay, I have to have the same x, same y, and same z. Okay, so x is equal to t plus 2, which is also equal to s plus 3. So is that consistent? That's 4. Yes, that works. Both of them are 4. Plug in the y. Negative 2t plus 3 and 3s minus 4. Okay, so negative 2t plus 3. Let me raise it up for you. Maybe I should start from the whole thing. You want to catch the video later. Okay, negative 2 times 2 is 4. That's negative 1. And is that true over here? Yes, they're both negative 1. Okay, if they came out to be different, let's say this was negative 1 and this was negative 2, that's a contradiction. So then we would say that the two lines are skewed. So far, it's consistent. X is 4, y is negative 1. And then z. Z is negative 3t plus 1. And it's also equal to negative 2s plus 2. Oh, negative 7s plus 2. Okay, so is that true? T is 2. That gives me negative 5. Does this give me negative 5? Yes, it does. Okay, so they do intersect at 4, negative 1, negative 5. Okay, and that's how you do that one. Now, if I got an inconsistency, if there was an inconsistency anywhere, okay, then I would get no solution. So both of these had to be 4, both of these had to be negative 1, both of these had to be negative 5. So that's where they touch. Okay. 12.559 was asked for. $12.559. Find symmetric equations for the line of intersection of the planes. Okay, so you have two planes. 5x minus 2y minus 2z equals 1. 4x plus y plus z equals 6. All right, so two planes in general, like this, there's a line of intersection, right? So one plane like this, one plane like this, they touch, and they touch in a line. So come up with symmetric equations for the line. Okay, and I think the easiest way to do this is just come up with 2 points. And you get 2 points, just arbitrarily pick one variable to be something that you quote unquote like, and then solve from there. Okay, so let's say z equals 0. And just see what happens. So that drops out, that drops out. 5x minus 2y equals 1. 4x plus y equals 6. So let's see. Multiply the second equation by 2, right? Multiply by 2, multiply by 2. I ran out of space, so I got to go back up. So leave alone 5x minus 2y equals 1. 5x minus 2y equals 1. This becomes what? 8x plus 2y equals 8. 8x plus 2y equals 8. Let's see, yeah. Okay, so 13x equals 9. X equals 9/13. Okay, not very convenient, but I guess that works. Okay, question about when do we give the answer I, J, K or X, Y, Z? Normally I'll accept either one unless I say specifically write it as I, J, K. Oh, well, when you do the cross product, right? The cross product, you know, you have to put the I, J, K on the first row. Okay, but other than that, you can use I, J, K or X, Y, Z anytime you wish. Okay. And let's see. 12.5. Ah, yes. 12.5 said to skip 21. Oh, well, we got good practice anyway. Okay, x equals 9 over 13. I gotta go back and find y. 5x minus 2y equals 1. Yeah, this is not going to be very nice. 45 over 13 minus 2y equals 1. 1 is like 13 over 13. Negative 2y equals 13 over 13 minus 45 over 13 is a negative 32 over 13.
Professor, I could be wrong, but it looked like below it was 6 times 2.
Right here?
Yeah. I think you might have
Times 2.
8 above.
What did I put? I added them, you're right. So that makes it much easier. Okay, I agree. Thank you. I thought I was going down the wrong rabbit hole. That makes this 12. You're absolutely right, and I'm absolutely wrong. Okay. 13x equals 13. I like that, right? So I was starting to get a sneaky suspicion that this was no good. Okay, 13x equals 13, x equals 1. Much better. So plug in 1 back here, I guess. That makes it 5. 5 minus 2y equals 1. And y is equal to 2. Okay, so 1, 2, 0 is a point. That works for both of them. Quick double check. 1, 2, 0, that works. 1, 2, 0, yep. Okay, then let's see. I have to arbitrarily pick another one. How about I would try y equals 0, which means I just cover these up. Okay, so y equals 0. 5x minus 2z equals 1. Four x plus z equals 6. Okay, so hopefully that's not too bad. Once again, multiply this one by 2. 2. So 5x minus 2z equals 1. And yeah, another good reason why you show all your work on the test, I can give you partial credit. Okay, obviously when I kept doing this, I was going to get it totally messed up. So I was not going to give myself full credit, but you know, I tried and all the steps were okay. I can give you partial credit. So make sure you show your work. If you do an arithmetic mistake, I'm famous, should I say, for doing arithmetic mistakes. So I'll give you partial credit. In fact, in this case, you know, I would give you most of the credit if the logic was good and just made an arithmetic error somewhere, which I might do over here too. So let's see, where was I? 8x plus 2z equals 12. Huh, I'm getting 13x equals 13 again. Oh, okay, be that as it may. 13x equals 13. X again is 1, which makes y equal to 2. Z equals 2. So 1, 0, 2. Check. Put a 1 here, 0, 2. That works. 1, 0, 2. Yes, it works. Okay, so 1, 2, 0, and 1, 0, 2. Okay, so how about I go from there to there? Okay, so 1, 2, 0 plus t times delta x, delta y, delta z. So from 1 to 1 is nothing. From 2 to 0 is negative 2. And from 0 to 2 is 2. All right, so x is 1 plus 0t, or 1. Y equals 2 minus 2t. z equals 0 plus 2t. Okay, so symmetric equations, I can't solve for t there. So I'll just say x equals 1 and t equals y minus 2 over negative 2, which equals z over 2. And that's about it. Okay. Okay, 12.6, 13, and 15. X squared equals 4y squared plus z squared. Okay, this one's fairly easy because it's similar. They all got the squares there, kind of. Okay, so x equals 0 means the yz plane. I have 4y squared plus z squared equals 0. That's just the origin. Right? Once you get anything like this, a positive number and a variable squared plus a positive number 0, z squared is 0. The only thing that works is the origin. 0, 0. Y equals 0 is the xz plane. Y equals 0. X squared equals z squared, so z equals plus or minus x. Slope of 1 and negative 1. And then z equals 0 is our xy plane. So put a 0 there. X squared equals 4y squared. Divide by 4. Y squared equals x squared over 4. Then square root property, y equals plus or minus 1/2 x. So slope of a half and negative a half. And there we go. And 15. Nine y squared plus 4z squared equals x squared plus 36. All right, x equals 0, which is the yz plane. Put a 0 there. 9y squared plus 4y squared equals 36. Divide by 36. Divide by 36. Oops, not 4. What am I doing? 4z squared. Y squared over 4 plus z squared over 9 equals 1. That's an ellipse, you might recall. YZ. So that is what used to be y, that used to be x. That's 3 units up and down. 1, 2, 3, 1, 2, 3. 2 units left and right. So if I were to look in the YZ plane, that's what it looks like. Okay, then y equals 0. So put a 0 right there. 4z squared equals x squared plus 36. Subtract x squared. 4z squared minus x squared. 36, divide by 36. Z squared over 9 minus x squared over 36 equals 1. That's a hyperbola. Z is functioning like y, so it's going to be the up and down type of hyperbola. Okay, so very crudely, okay, it's going to go something like this and like this. You might recall hyperbolas look like this. And z equals 0, pretty much the same thing. Z equals 0. 9y squared equals that. subtract x squared, 9y squared minus x squared equals 36. Divide by 36, divide by 36. So same thing, y squared over 4 minus x squared over 36 equals 1. Hyperbola going up and down again. So same general shape. The steepness might be different, but I'm not concerned about that right now. So again, it's going to be something like that. Oops. The paper's curling on me. Try to uncurl it. And yeah, let me go back and raise it up for focusing purposes. I want to watch the video later. Okay, so let's see. I think I've caught up there. All right, let me go back to the chat and see what else I have. So we don't need to be exact when we do the traces. Yeah, rough sketch. You know, y equals x, crudely like that. In general, plus or minus a half x, so just roughly something like that. Okay, let me check what else in the chat. Caught up there. Okay, I did that, I did that. Okay, to show two vectors are not parallel, can we take the cross product and show that it is not the zero vector? Yes, that certainly works. The easier way, though, is to just see if one is a scalar multiple of the other. But yes, that would work. Cross product is non-zero. Because if the cross product is zero, then that means they're parallel. So yes, that would also work. Okay, I think I've caught up, unless I'm missing something from the chat, because it's hard to, you know, lecture and read the chat at the same time. So if I missed your question, ask again or unmute yourself again, please. Okay, 12.6, number 14, XY plane. Okay, 12.6, number 14. I believe I already did that one, so maybe I'll just whip out what I did before. 12.6, number 14. Got my pen here. Okay, 12.6, number 14 was like that. Okay, XY plane means Z equals 0. So negative 4x squared minus y squared equals 4. I multiply both sides by -1 to get 4x squared plus 4y plus y squared equals -4. That can't happen, so there's no graph. There's no graph in the XY plane, right? That's impossible. Right there. Okay. All right. And let's see, I believe I've caught up again. So does anybody else want to ask something? Otherwise, I'm just about done. I might sneak in very little of the next section and then we'll quit early. I'll let you ask questions again next time, but again, the more we do today, the fewer we have to do next time. So anybody else, I'll let you have some time for that. If I missed your question, ask again, please, because you know it's hard for me to look up and down all the chat. Wait just a little longer. Okay, I don't hear anything, so I'm going to lecture very short time, and then we'll probably end early. Okay. So I did all I was going to do for 12.1, 13.1. So what is 13.2 about? So I'll just tell you what it's about, and then whatever I do now saves me time next time. So next time I will lecture part of 13.2 at the beginning, and then I'll stop, let you ask questions, and then we break, and then we take the test, right? And if we aim it for it right, I can give you more than 15 minutes, as it were. Okay, so just an introduction to 13.2, and then we'll quit early. derivatives and integrals of vector functions. Page 855. The derivative r prime of a vector function r is defined pretty much the same way as it is for real value functions, as you might guess. You don't really have to write it down because you're not going to have to calculate any of these. The derivative of the vector r with respect to t, or r prime of t, is, remember from Calc 1, limit h approaches 0 of the vector function r of t plus h minus r of t divided by h, if the limit exists. Okay. What is actually happening in space, if you have a space curve, and I say space curve, it could be a plane curve. If it's two-dimensional, then just pretend it's three-dimensional and z is 0. So you can think of this as the passage of time, right? So let's pretend the particle is moving like this at one particular part in time, or at a point. This could be at the point, 3, -2, 6, or whatever. Or it could be at time t. Then this is a tangent. You could say that's the direction that we're heading at the moment, right? So think back to Calc 1, when you were doing Calc 1, right? And you had a curve that goes like so or whatever. You get the tangent, right? The tangent tells you that's where you're heading at that moment. Same thing here. At that moment in time, in 3 space now, remember you got a space curve. It's going like that and like that and like that. Maybe think of a roller coaster, a 3-dimensional roller coaster. At one moment in time, okay, you're going this way. And then by the time the roller coaster moves here, now your tangent is this way. And way back over here, your tangent is this way. So it could be like that and like that and like that. You're all over in 3 space. And any of you who ride roller coasters, that's the way it is with roller coasters. You keep moving the tangent vector. Okay. So how do I take the derivative? Okay, it's not that big a deal. Okay, so remember, we're calling it one function, but there's really 3 functions underlying it, right? X, y, and z. You just take dx dt, dy dt, dz dt, the derivative with respect to t for f, g, and h, or f prime of t, g prime of t, h prime of t, I, j, and k, right? So we call it one derivative, but even though we're calling it one derivative, you're doing 3. So for any one question, right? So if this is question 5, this is like 5a, 5b, 5c, or even more accurately, 5x, 5y, 5z. Okay? So we're going to use the language, we're doing one derivative, but the one is made up of 3. Okay, so you open it up and there's 3 parts to it. Okay, the x part, f prime, g prime, the y part, and the h prime, z part. So to take a derivative, you just differentiate that, and that. No big deal. It's like doing 3 in 1. Take 3 derivatives in the same one problem. Okay. Now, there's going to be more stuff that you put on your new formula sheet. Let's see. We have that. Unit tangent vector. Unit tangent vector, well, we know what a unit vector is, right? Magnitude is 1. So r prime divided by norm of r prime, just as we expected. So in case you need a unit tangent vector for some reason, just divide it by its magnitude. R prime divided by magnitude of r prime. You can put that on your next cheat sheet. I would advise you not to even fiddle with it until after the test. Page 858, differentiation rules. You can look at it or not. Okay, you don't have to memorize any of them. And in my opinion, you don't really have to write any of them down. This seems to follow just from Calc 1, right? The derivative of a sum is a sum of the derivatives. The derivative of a constant times a function is the constant times the derivative of the function. This looks like a variation of the product rule, right? F of t, u of t. Notice that f of t is a scalar though, and u is a vector. F prime u plus f u prime, kind of like the product rule. The derivative of u of t dot v of t, derivative of u of t cross v of t. Okay, we actually don't do a whole lot of problems involving this. In fact, maybe none. So I would say don't even worry about memorizing. Well, definitely don't memorize it. You can write it down, but they're there. They kind of look like a product rule. And that looks like a chain rule. Derivative of u of f of t, okay, f prime of t, u prime of f of t. Right? So very, very similar to what we had in Calc 1, only now we have vector functions. Okay. Integros. Not that big a deal. You have a function f of t, g of t, h of t. How do you integrate the whole thing? It's 3 integral problems. Integrate the x part, y part, and z part. That's all. It's like 3 in 1. So we're going to say one integral, but the one integral has 3 pieces to it. Okay? You just do 3 integral problems. Part A, part B, part C, or more accurately, part X, part Y, part Z. Okay? It's called one integral, but that one integral is made up of 3 parts. Okay? X part, Y part, and Z part. Okay. And yes, that's a shortcut way of writing. That looks like Calc 1, right? Integrate, plug in the upper limit, plug in the bottom limit, and subtract, which is exactly what's going on there, and there, and there. Okay. And then after that, we start doing some homework problems involving that. Okay, but I think you can see it's not that big a deal to take the derivative. Like just look at 17. How do you take the derivative? Just differentiate all 3 of them. Right? They're not all that easy, and we do have to do some graphs, okay, of a position vector. Okay, again, look at this position vector. Position vector means it's always coming from the origin. So that looks like a 2D vector, R4, 5, R4, 2, R4, or whatever. Okay. So next time we'll be doing some of these. We might be asking for the derivative, find a tangent vector, which means just differentiate. Okay, we'll be sketching some position vectors. Some of these look like a 2D, and some later a 3D. Okay. Dare I say finding the derivative should not be that big a deal? And look down here. Find the derivative of the function. Just differentiate all 3 of them, right? Unit tangent vector. Okay, unit tangent vector, once you find the vector divided by its magnitude to get a unit tangent vector. Okay, and we got to compute a cross product. Good practice for the test, I suppose. Okay, find parametric equations for the tangent line of the curve. Okay, so we'll talk about how that's done next time. And we have some integrals. How do you integrate? Just integrate all 3 of them. Right? It's 3 integrals in 1, so to speak. All right, so that's what I was going to say. I'm finished, folks. And some of you put something in the chat. So let me double check that, okay? Let's see. Okay. Okay, something about the homework. Okay, so there's really no homework grade, okay? If it looks to me like you did it, then you get credit for it, okay? The only thing you should think of the homework is if you don't turn it in, I don't grade your test, okay? But there's no homework score per se, okay? So I don't grade the homework. I mean, you've got the answers in the back of the book also, so that's that. Okay, and let's see. I think I did that. I did that. Okay, I think I've caught up. Yeah, so obviously, do the homework. The questions are going to be just like the homework on the test. And, that way I can look at what you did. Okay, so again, I look at the writing on the homework and the writing on the test. Hey, the writing on the test doesn't match the writing on the homework, then I get real suspicious. Okay, and part of my philosophy, I know this doesn't cut out all cheating, and I know it's a lot easier to cheat under this circumstance as others, but you might get someone to cheat for you on a test, but you're much less likely to find someone who wants to do all the homework for you, right? because, you know, I have to look at the writing and see that the writing is similar, so to speak. Okay, so let's see, other than that, if we just have, so next time I'll do section 2, Q&A session, and then break and then test. So if I give you more than 15 minutes, you know, fine, maybe 1.5 hours, that's okay also. Okay, so does the integral give any similar thing? We'll see lots of applications of these things later on. But yeah, as you can imagine, when we're in 3D, we're going to get surface area, we're going to get volumes and other neat stuff like that. Okay.
If I wanted to make like a double helix with the parametric equations, is there a way I could combine like a sine wave in like one plane and then a sine wave in like a perpendicular plane?
Right. I know you mentioned that. I decided not to cover that because that's going to lead us down a rabbit hole, which I'm not requiring and would be too confusing. So yeah, sorry, I'm not going to cover that. If you wish, you can look it up on the internet, I guess is the best I can say. But yeah, I'd rather not discuss that. So sorry about that. Okay. Okay, other than that, I think I'm done. So anybody else want to ask something? You still may. It's only not even 8 o'clock yet. Otherwise, we're done. Okay, hearing nothing and seeing nothing, we'll call it a day. All right, so get your homework ready. You can start submitting the homework now if you wish, but the latest I will accept it is half an hour after the test, right? So the test will end at a normal ending time of 8:25. Then you take pictures on your cell phone and click, 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 give it to me by 8:30, and the homework has to be submitted by 9:00 p.m. Thursday. But if you want to submit it early, that's fine too. All right. All right, that'll do it for tonight, folks. So everybody have a good night and see you next time for the test. All right, bye, everybody. Good night.
Thank you,
Have a good night.
Night.
Thank you.
Professor.
Night.